So hello everyone. I will be talking about the topics of anisotropic materials characterization by the circular birefringence determination. So I will try to show you how analysis surface can allow us to characterize anisotropic materials. So firstly and briefly, so I will be talking about the notion of rotatory power. So it is a property of materials. It corresponds to its ability to rotate the plane of polarization of light, which passes through it. And at the end, we have a shift in angle when we compare the plane before and after the plane of light when it passes through the materials. So we can easily understand the fact that it is proportional to the thickness, and it is also inversely proportional to the square of the inverse of the square of the wavelength. So it is specific for material, and however, because of the presence of optical twins of Machels, this rotation, so the rotatory power, could be affected. So surface analysis, here we have a manual polarimeter. Here we have the light source, the polarimeter part, polarizer part, analyzer part, and we have a thin slab of our birefringent materials. So we rotate the analyzer and we observe all these kind of surfaces, all these configurations, and we can see all these discernible zones without this manual polarimeter. So thanks to analyzed surface observation, we can now distinguish some discernible zones and barrier walls. So because of this distinction, we can now proceed to characterize our materials. So we have a spectrophotometer. Firstly, we realize the measure of P. That means we record the transmission which passes through a polarizer first, then PA for polarizer and analyzer, and thirdly, PCA for the transmittance which passes through a polarizer, crystal, and analyzer. So we can imagine like an optical bench mounted inside our spectrophotometer. So we realize these measures for each wavelength, which are in this range of wavelengths, and our analyzer will rotate between this range of angle. So we then determine some transmitted power as a function of polarization angle for each specific wavelength. Here we plot PA over P and PCA over P. We can see the same shape, but with the shift here. The shift corresponds to the angle that I told previously, the angle of the rotatory which corresponds to the rotation of the polarization of plane, the plane of polarization of the light. So thanks to this shift, we can easily determine the rotatory power for each wavelength, and we can plot then plot the dispersion rotatory power of our material regarding the wavelength. So yes, we can then plot the intensity regarding the polarizer rotation for each different zones determined previously, thanks to our analysis surface observation. And we can then determine R, which corresponds to the apparent rotatory power. That means the rotatory power of each selected zones over the rotatory power rho, which is the rotatory power of a thin slab, but which is empty of optical twins. So yes, to conclude, thanks to our observation made by surface analysis, we can observe the fact that it could be used like a tool to characterize some birefringent materials. So it could be used for this kind of project. for the type 2 modifications with thermal stability by infrared femtosecond laser and silica-based glacis, and for the thermal erosion mechanism of femtosecond laser induced nanogratings in silica glass. So thank you for listening.